Hello, I'm David Tao, and welcome to the Theories of Everything program on Channel. Viewers, this is the first in a two-part update series in which we really look at the state of the planet. By the state of the planet, I mean the effect of global warming, whether it's real or not, the impact on biodiversity, the impact on animal and plant life, the impact on humans, the potential impact in the future, and whether in fact the planet is capable, whether Earth is capable of sustaining the sort of lifestyle that we expect in the future. Around about 18 months ago I did a series on theories of ecosystems in which we examined some of the parameters relating to the status of the huge number of variables that govern the planet, such as the complexity of the ecosystems themselves, that is the combination of all the factors, the humans, the plant life, animal life, oceans, atmosphere, etc., that make up the biosphere, the totality of this Earth and its atmosphere. We examined those parameters and they were fairly grim at the time because there were signs of global warming, there were signs of sea levels rising, there were signs of loss of animal and plant life, biodiversity. In fact, there are a large number of indicators that showed that all was not well. And this was pretty commonly known. It appeared every now and again in most newspapers, etc. But in that intervening 18 months, not a lot has happened. In other words, governments seem to have hedged their bets largely in that time. And in that time there's been a major increase in the risk factors relating to these different parameters, relating to these ecosystems. And still the mythologies go on about the uncertainty of the factors relating to global warming, whether it's real or not. But in fact, over the last year, and particularly over the last 6 months, there have been a number of very disturbing reports clarifying and, if you like, eliminating a number of these myths. For example, if we examine the state of global warming itself, it now appears that man-made factors, the clearing of land, the burning of fossil fuels, all the other factors that humans have brought to this planet, particularly since the Industrial Revolution around 200 years ago, are in fact kicking in and dwarfing any other normal, if you like, background factors such as volcanic eruptions, variations in the sun's output, etc. These do occur, but they occur over very short terms. For example, it appears now over the last century that there has been a rise of around about 0.6 degrees centigrade, and that has caused a rise in sea level through expansion plus some polar melting of around about 25 centimetres. But this trend is now accelerating, and the projections have been done by these reports showing that by 2050 the levels will have risen. First of all, the temperature will have risen by at least 2 degrees centigrade, and the levels of seawater will have risen at least by half a metre, if not closer to a metre, certainly by the end of the century to around about a metre. So the first myth, that the uncertainty relating to global warming could be explained by natural factors, has been proven to be by a number of reports now just that, a furphy. One of the biggest indicators, apart from the continuing rise in temperature itself and the rise in sea levels, has been the rise in the amount of carbon dioxide, one of the major, obviously the major global warming gases, apart from water vapour itself. The percentage rise has been around 30% of carbon dioxide over the last 100 years, or certainly from pre-industrial times. It was around about 270 parts per million. It's now gone to about 370 parts per million. Now, the significance of that is, first of all, that that's the highest level of carbon dioxide that's been able to be measured in the last 420,000 years. This is a real rise, and it's higher than anything in the past 400 odd thousand years. Now, how do scientists know that? Because they've taken core samples from the previous glaciation period, and they've taken them down to levels that go back to around about 500,000 years, and you find little pockets of air in those core ice samples, and they've been analysed and they show the levels of carbon dioxide. So despite the fact that there's been various impacts such as volcanoes, volcanic eruptions occurring in that time, this is by far the highest level, and it has been reached just in the last 100, 150 odd years, and it's going up. The trend is that it will continue to go up, so that around about by 2050, roughly another 50 years, it'll be up to around about 550 parts per million. So this is a very big indicator and proof, if you like, apart from also the heat that's been measured in the ocean going down 3,000 metres. Roughly 18 by 10 to the 22 joules of energy has been absorbed in the last 50 to 100 years by the oceans. So these are the measurable, real increases that are indicators of true global warming, man-made, anthropogenic, as the term is called. But we can see it around us, because in this last decade, for example, that has been the hottest decade on record. For a start, Italy's had the hottest summer ever. Europe has had the hottest, the greatest number of heat waves ever recorded, for example. So it's on record that the heat is increasing, and of course with that heat has come more extreme events. As the sea levels have risen, so have also storm surges, not just the levels of water that are important here, but the extreme events that go with that increase in temperature, including storm surges, so that there's been an enormous increase in floods across Europe again, heat waves, floods across Europe, and droughts, of course. There's a severe drought both in Africa, I think it's been going on for 3 years, and certainly in parts of Australia for 3 years. Floods and droughts, again, have always occurred according to fairly rhythmic cycles controlled by the El Nino southern oscillation process that brings rain and dry weather to certain areas of South America and Africa and Australia. However, again, the frequency and the intensity of these floods and droughts and storms and even things like tornadoes has increased, and it's increased alarmingly over the last decade or so. It's increased to the level of where there was used to be one flood, one drought every 3 years or so, major flooding, major droughts. Now that's increased to three extreme events per year, from 1 in 3 to 3 in 1. So basically a 9-fold increase. And that's occurred again just over relatively recent times. But most alarming from the reports that have come out in the last year or so have been that if this continues, if this projection of temperature increase by at least 2 degrees, going up to 3.5, 4 degrees by the end of the century continues, these floods and droughts and extreme events will increase 30-fold. So, and the damage wrought by those floods and droughts, of course, is massive. It's been estimated that in the United States alone, the cost of floods and droughts, and of course we've seen the extreme weather in New York just recently, but there's also been massive tornadoes much greater than the normal level. The cost in 2003 to the United States alone has been of the order of $60 billion. In Europe, the cost of the flooding, the cost of the heat waves, apart from life, has been of the order of $10 billion. In the Yangtze flooding, the cost of that was $8 billion alone, just that one major flood in the Yangtze. Cost to agriculture, cost to homes, urban infrastructure, etc. And the cost in lives in France, for example, from the latest heat wave has been estimated, fatalities direct and indirect have been estimated at around 1,500. And again, reports have come out saying that this can only increase, so we have got incredible risks emerging if this continues. The object now is to hold the line to a certain extent, to try and reduce these emissions, but to hold the increases if possible. And that's going to be very difficult because the momentum, it takes a long time for carbon dioxide to dissipate from the atmosphere. Stuff like aerosols, dust, etc. can dissipate fairly quickly within weeks, but it takes years and decades and perhaps hundreds of years to reduce once the momentum builds up, largely from industrialisation, which is going ahead at a great rate. It takes a long time for that to reduce back to normal levels. The idea with the Kyoto protocols is to reduce levels of carbon emission back to pre-1990 levels by the year 2012, whatever. But still, the existing momentum of the carbon emission will continue, it will still exist, and the heat feedback effects will continue. Once you get that thing moving, once you get the feedback moving. For example, also what has been occurring in recent times has been the melting of the snow caps and the so-called ice shelves, and that's been very apparent too, as shown by satellite maps. But once that occurs, you reduce the albedo effect. In other words, you reduce the amount of reflection of heat from those ice caps because there's more dark water, if you like, so there's more absorption of heat, and that creates a speed up in the warming effect. So the momentum and the massive changes in energy within our atmosphere, within our biosphere, can't be halted. They can only be slowed and perhaps stabilised somewhere around the mid-century. So that is the current hope. Because, again, if we don't stabilise it, we're in for massively more extreme weather, massively more greater damage. Disease, for example, impacts on health will be enormous. At the moment, malaria, or the mosquito parasite, covers around 45%, is extended and affects around 45% of the population. If there's a warming of around 2 degrees, that will extend to 60% of the population. So, but not only malaria, but Nile River fever, dengue fever and so forth, a host of other tropical diseases, sleeping sickness, will affect many more of us. So if we come back to flooding briefly, the impact of a ½ metre, which is quite probable by the mid-century, or 1 metre toward the end of the century, will be huge indeed. It will cover around about, or cause flooding of around about 2/3 of Bangladesh, for a start, let alone the Pacific Islands. And even our Kakadu Park, the north of our Australia, is only about a ½ metre above sea level on average. So it will cover that. It will cover many of the coastal areas of India and Japan and the Philippines, as well as places like the Gold Coast. Because again, it's not just the average rise, it's the additional storm surges and extreme events, the king tides, etc., that amplify that sea level rise. Now, I think that there's a barrier. For example, there's been a UK report brought out showing the potential devastation from floods in that country, around the coastline of that country. I mean, the coastline of the UK and Wales is around about 3,700 kilometres. The damage, not only to property but in erosion, is potentially enormous from this increase in floods. But the Thames itself, which is affected by, again, waves, surges and storm surges, they put a barrier up, and once every 6 years this barrier has to go up to stop flooding. Now it's going up on average at least once a year. If one flood occurs, breaks through that storm barrier on the Thames, one river alone, it will cause around about 30 billion euros damage around about 60 billion, around about 30 or 40 billion dollars, from one impact event, from one flooding event. Now, it's been estimated that to hold the line on carbon emissions to around about 550 parts per million, which still allows for another 30% rise, will cost in GDP terms globally around about 1%. But in fact, one flooding, if that's not done, one flooding of the Thames costs around about 2% of their GDP. So in other words, the risks are of not doing this stuff. As I said, there's been $60 billion worth of damage done in the US alone through flooding, storm surges, through directly attributable to global warming just in the last year. So we can see that even in the last year, there's not only been a much greater narrowing, if you like, of the uncertainties relating to global warming, a much greater consensus by scientists, environmental scientists, biologists worldwide, that this is real, that it is ongoing, that it is building, the potential risks involved. There is not just these constant alarm bells ringing, but we can see it all around us every day in the way that our weather patterns are changing and the way our agriculture is affected. So viewers, what's really driving this rush towards the inevitable annihilation of our planet, the greatest threat that we can be exposed to? I mentioned the threat from a rogue asteroid. But the rate now, the evidence pouring in to show the rate of global change, which will trigger massive climatic events, huge floods, huge droughts, continuously, eroding our land, forcing the relocation of a large proportion of our populations, causing massive damage to our infrastructure. This will inevitably continue, or inevitably reach its climax, if you like, if we don't stabilise the situation. The United Nations has brought in a framework for climate change control, in which it's trying, not only going way past the Kyoto Protocol, to try to get the levels of carbon dioxide 60% below 1990 levels. Kyoto aims for 12%. That's the only level in which we can stabilise what we're already doing to the planet, stabilise the damage, stabilise the negative results. We haven't mentioned the impact on biodiversity, the fragile ecosystems all over the planet, not just in the tropics, but in the coastal areas, the reef systems, the Arctic areas, the desert systems. All these are fragile, balanced in equilibrium, or a constant ability to reach equilibrium, ecosystems that maintain the quality of life, the quality of air, the quality of water on this planet. But they're rapidly being broken down. We're losing species at an alarming rate. Reports are showing that if this global warming trend continues, by 2050 we'll have lost 25% of species on the planet, which means the complete breakdown of all ecosystems virtually. In Australia, we'll have lost 80% of our forest species, plants and animals, if this continues. You can't just take out major predators such as lions, which have crashed from 600,000 to 60,000 in the last 10 years, let alone smaller animals like amphibians, smaller animals like the Tasmanian devil, which control foxes. When foxes are uncontrolled, they take out all the native animals. Huge ripple-through events occur. If you damage through ultraviolet the plankton in the sea, that goes right up through the chain, right to the top levels, to whales and to humans. All these things start crashing because they inevitably change, but they've had over the eons time to change. We are forcing now change in several hundred years that would have taken at least several millennia, if not several million years previously. But remember, we're getting a massive rush of energy from the sun constantly. So if you vary, we're getting 175 petawatts of energy, or quadrillion watts. 1 petawatt is equivalent of energy is equivalent to 1 million 1,000 megawatt power stations, which is a pretty large power station. So 30% of that is reflected, 70% absorbed by the oceans and the land, etc., and the clouds, and the atmosphere. So if we change the energy flux within the atmosphere, within our biosphere by 1%, which we're starting to do, you can see the enormous shift in energies that will occur, which will have massive ripple-on effects. They'll affect all our ocean systems. Our ocean currents won't continue to flow the way they do. They'll reverse and flip, just as the El Nino is increasingly doing that at the moment. The El Nino Southern Oscillation Current, causing droughts and floods and so forth. The drying up of the monsoons in India. So all these things are going to rapidly implode unless we bring this headlong rush to some form of stability. And of course it's caused partly by human population growth. In 1800 there were 1 billion people on the planet. 1900, 2 billion. 1950, 3 billion. 2000, 6 billion, going up to 9 billion, slowing, but going up to 9 billion by 2050, with all the ramifications for industrialisation and energy usage. As I mentioned in a previous energy program, there's a switch now. The risks are starting to be understood, and there's a gradual switch to renewable energy in the hydrogen fuel cycle, the hydrogen fuel cell, as opposed to combustion fossil fuels, natural energy, gas. But with 600 million more Chinese consumers and another 600 million Indian middle-class consumers wanting to get to the same standard of living as the West in the next 10-20 years, it's going to be very difficult to make those switches in time to save the planet. And we'll end up, viewers, with a planet pretty similar to that. In other words, a dead planet that you see in the film The Matrix. We'll be cushioned against it, air-conditioned, etc., but the minute you walk outside you'll have a dead planet. As we've said on many programs, there appears to be a vast amount of life in the universe, but whether any of it has developed to our level, the level of this pale blue dot, as Carl Sagan's book in 1994 was called, after the tiny, tiny little blue image from Voyager 1, 6 billion kilometres away, was reflected back to Earth, was transmitted back to Earth. He said in that book that planet Earth was just like a speck in the great cosmic dark, and it is, and it may well be the only one that sustains our sort of life. So to risk it for political reasons, for short-term expediency, to satisfy a few vested interests, is at best just phenomenal madness and disregard for future generations. I'm David Tao, and you've been watching the Theories of Everything program. I'll look forward to seeing you again next week. A speck in the great cosmic dark, and it is, and it may well be the only one